I think you see the question on the screen. So as a designer, would it be fair to say that we should apply both standards 62 and 241 and apply the highest requirements specified at all times, both for design and operation of the system?
Sure. Well, you should apply both to the design and capability of the system, but as I explained, 241 explicitly defines an operating mode that isn't intended to necessarily be used all the time. That's something that a user could decide to do, but it's not considered to be a requirement that you operate that way all the time. If you did it, you would be, I suppose, setting minimum outdoor airflow by 62.1, for example, and then providing whatever it takes to get to the ECAI requirement by other means. Otherwise, you would be superseding 62.1.
Okay, thank you. So questions which I think are more or less can be replied by all is first, so a common thread in all standards as well. Actually, EU, India, Singapore is a difference between periods with or without a pandemic or contamination risk. During such periods, higher ventilation rates or higher filtration levels kick in. For a new HVAC design, this means that systems must all be designed to be able to comply with a higher risk whenever necessary, which will make them more expensive probably. Can you please comment on this and on the energy efficiency, energy consumption consequences? Who wants to reply first to it? Bill, can you?
I'll be happy to say something. As far as cost, it's likely there would be some increased initial cost, but in terms of cost effectiveness, the economist that we have on our committee has already published a cost effectiveness analysis that shows that the standard more than pays for itself in reduced health impacts. As far as energy, I just don't accept the notion that we can't have better IAQ and maintain our energy goals. And we've already had one article published by a member of the committee that shows that can be the case. I would also say that if we simply do better maintenance, we'll save enough energy to pay for anything we might do in terms of increasing energy to have better IAQ.
Okay, thank you. Chandra, you want to say something?
I just want to chip in here again that there could be a marginal increase in cost because you are putting some capability in the design and thereby in the installation of system components. I suppose the biggest advantage, the way I see it, would be the ability to be able to adapt the operational side of things as and when the need arises. So that's something that I guess world over we realized that systems did not have the capacity, or they were not in a position to be able to handle the varying demands. So in that context, I think building in a certain element of resiliency in the system is definitely a good idea. And surely, I mean, there are energy implications, certainly for us in hot and humid climate, with very high energy penalty for outside air treatment. Hence, the whole notion of treating the recirculated air and bringing that part into the whole discussion about mitigating the transmission risk is an important part of it. And you got to put in the requirements that will help us achieve that, which is enhanced filtration or disinfection or the other type. And I think I'll go one step further to say we have not even discussed much about the air distribution side of things, because therein lies the ability to be able to manage things at a very occupied zone level, if you like. So there are new engineering innovation that can potentially happen here, new ways of distributing the air. Jarek already spoke about ventilation effectiveness. These are things that could help us in, adapting the design to an extent that it can make the operational side more meaningful and effective.
Okay, thank you. Anyone else want to react to this question? If not, I see that Jarek is there. I think we can go back. Yeah, Jarek, you want to reply?
Yes, I think I am not able to reply about this electrical panel rooms and So this question, I don't exactly understand what is meaning. We are just speaking about common rooms, but one short comment about the energy implications. So if we speak about equipment which is with higher capacity, so bigger air handling units, perhaps some improved air distribution, when we mostly speak about increased investment cost. But this can also provide energy savings, because if system is mostly operated on demand-based, then high capacity system can be more effective at low air speeds. So it is not necessary more energy use, but can result also in energy savings if correctly operated, because these epidemic periods likely will be quite short in time and no need to operate at the full capacity.
Okay. So Jarek, there was one question for you. You see, I think at the screen here, so why in your presentation is point source effectiveness averaged over different locations of infected persons instead of applying the lowest effectiveness?
Yeah, so there is the idea that we do not eliminate this infection risk in common buildings. So this is the reason we still calculate some sort of average ventilation effectiveness. However, we conduct these measurements with different infector locations. And indeed, we should be aware if some location will result in very high infection risk. But yes, a common procedure what is proposed is to use at least 2 measurements with 2 infector locations and then to calculate the average value.
Okay. Then a second question for you. So in the European standard under development, airflow rates are different during periods when contamination risk is present. So the question is, who defines them? Are it the national health authorities, building owners? So can you please clarify when to apply the rates for contaminant risk?
Yeah, I think this is a national public health authority which will provide information about epidemic periods, and it worked quite well during COVID. But yes, if we have some new epidemic situation, when it is we just expect that public health authorities will tell to us when we have high epidemic infection risk.
Okay. Bill, there is an additional question for you. So the question is, I'm confused. Yeah.
Sure, I see the question. I'm not sure that ASHRAE actually is separating pandemic and endemic operating conditions in the way shown. Again, the requirements can be applied based on perceived risk, and acceptable risk is determined by authorities. So an endemic disease could invoke the operation IRMM, but we developed this standard in 4 months based on characteristics of a pathogen that were pretty much like SARS-CoV-2. We're talking here about future developments that gets into some of the other general questions of being able to specify parameters for endemic and possibly seasonal diseases. So I don't see this standard as not applying to them, but I think it's something that's more in our work plan because of the time constraints on getting the initial version out.
Okay. We have, I think, still 2-3 minutes for a few more questions. So here the question is source control. So the prevention of aerosol entry to the indoor environment, such as through occupant masking and occupancy control, allows lower ventilation rates to be used for contaminant dilution when appropriate. Will the standards be updated to address source control issues? Anyone willing to reply to it?
Well, source control, it means getting infected people out of the building or putting masks on them for the most part. Or if you know someone's infected, I suppose applying air control. Some of those things are HVAC related, and some of them are not. If they relate to testing and quarantine, I don't see how we can put them in the standard. I mentioned before that we're working on a performance-based model and a calculator that would allow parameters like are people wearing masks and at what level to be specified. So I think source control assumptions could eventually be incorporated. They aren't there now. We assume no masks.
Yeah, it is the same as the European approach. So no face masks taken into account in the calculations. However, these are a kind of additional complementary measure which can be used, but not taken into account in the standard.
Yeah. Anyone wants to react on it? No?
Well, I suppose when we are talking about controls on the system side, we're talking about engineering controls. So face mask is more of a personal protective equipment sort of thing, PPE control, and we leave it to the individual to enhance whatever protection they want to have at their own individual level. But from an engineering control perspective at the system level, that's probably what the standards are talking about.
Okay. Another question, so the standards purposes are in part to reduce the risk of disease transmission, but none seem to provide the procedures for determining risk, nor provide the risk of contaminant spread and associated disease for specified ventilation rates. Will this information be provided so that designers, operators, and commissioning agents, as well as public health officials, can evaluate whether the system of controls achieves the intended purpose? Anyone likes to react?
Well, that's definitely the direction we're moving. Again, to go back to my point that we developed a standard very quickly with one set of risk assumptions. We assumed a level of infection risk. We assumed the probability of an infector being present based on the number of occupants in the space and the community incidence, and we assumed 0.1% probability of infection for 1 hour exposure. So those are parameters in the model, and we're moving in the direction of making the model available so that if a public health authority wanted, or someone else wanted to look at other scenarios, if they had different views of what's acceptable risk, they could do it, but we're not there yet.
Okay.
Yeah, exactly. These are in the behind of these equations we've shown. And indeed, they are also published in the scientific literature.
Okay. Then a practical question. So are there examples of application of equivalent airflow in current HVAC design practice and operation? For example, based on HC 241 or the IN standard?
Yeah, there are some examples provided in this REHVA guideline, what was shown in my slides. So this provides what is common design today in common spaces and comparison with infection risk-based ventilation rates.
Okay. And then, yes, ventilation effectiveness values imply that the standards assume a well-mixed breathing zone. Will other metrics of interest, such as contaminant removal effectiveness and spread index, be included so that the user can assess how well the system contains the contaminants or prevents it from spreading from one location to another? So
ventilation effectiveness, we speak in the European standard, and actually it's the same in US. This is actually contaminant removal effectiveness, based on the contaminant removal effectiveness, but we just use a point source for these measurements. And the previous values have, in the literature which are available, have been measured with distributed source. So this is the difference. But yes, it's mainly contaminant removal effectiveness. What is the value we should use in this design?
We believe it's important, but it was also one of the most difficult things we could deal with, because some of our concepts of ventilation effectiveness don't work when you put air cleaners into space. For example, displacement may be better for indoor air quality generally, but if you're using upper room germicidal UV, a well-mixed space actually increases the performance of the UV system. So, and I just don't think that the research is there yet on what happens when you start putting pretty high flow rate air cleaners into existing spaces that already have an air distribution concept. So it's a high priority, but it's not the easiest one to come up with answers that can go into a minimum standard.
So
Okay.
also, if I may add in here, Peter, the whole question of air distribution and its impact on how we could address the exposure control in terms of what the person is exposed to. Therein comes your personalized ventilation, local source control, exhaust. All these are important considerations which we're not quite there yet, as Bill has just described, but I'm sure certainly the effort will be there to incorporate some of the scientifically established research findings into practical application moving forward.